All right, let's see how to calculate the percent composition by mass of each element in a compound. And you may be asked to calculate the percent composition for one specific element, or in the example I'm going to show you, we're going to do this calculation for each element in one compound. So the definition and the way to calculate this percent composition specific to one element in a compound is you take the mass of the element, usually in grams or grams per mole, and divide that by the mass of the compound, and then multiply by 100 to make it a percent. So in this example, I want to take a look at calcium phosphate, and you need to know the formula of your compound, and you'll also need to calculate its molar mass. So the first thing we need is the molar mass of calcium phosphate. I've already calculated that. It has a mass of 310.18 grams per mole. So we'll need that in all of these calculations. So let's go through element by element and calculate each element's mass percentage in this compound. So the percent of calcium by mass in this compound is the mass of calcium in the compound divided by the mass of the entire compound. And the only tricky thing here possibly is you've got to remember to multiply by the number of times the element appears in the formula. So for calcium, we need to multiply its molar mass by 3. So 3 times 40.08 grams per mole for calcium. Let's divide that by the molar mass of the entire compound, 310.818 grams per mole. Multiply by 100. This compound, calcium phosphate, contains 38.76% calcium. And we can go ahead and do this type of calculation for all of the elements in this compound. So next, let's calculate the percent phosphorus. And the phosphorus atom appears twice in that compound. So let's take 2 times the molar mass of phosphorus, which is 30.97 grams per mole. And then again, we'll divide by the molar mass of the whole compound. Times 100. That gives us about 20% phosphorus. And then we can do the same thing for oxygen. And oxygen, there are 8 oxygen atoms in 1 mole of this compound. So 8 times oxygen's molar mass, 16 grams per mole. I always round to 2 decimal places because that's accurate enough. And you don't want to spend time on an exam or a quiz writing down all the digits you see on your periodic table or punching them into your calculator. And for this type of problem, there are no significant figures, right? Because you're just looking up the numbers on the periodic table. So the percentage of oxygen in this compound is 41.27%.